Hi, hello friends. Welcome to T Academy. In this video, I am going to provide the solutions of the Tsnpdcl AE question paper, which is held in the 18/11/2015. So this is the one of the tough question papers of assistant engineer paper, right? So let's discuss the solutions of this question paper here. Right, the first question here it is on the screen as you see. The damper winding is provided in a three-phase synchronous motors too. So damper winding is provided in synchronous motor. So where the damper winding is provided? Damper winding is provided in the rotor of the synchronous machine. Okay, there are two types of synchronous machine based on the rotor construction. That is, the first one is a salient pole, as you know. Second one is cylindrical pole. Okay, cylindrical so pole. These two are the rotor type constructions here. Now in case of this salient pole rotor, like this, the shape is a dumbbell shape like this, and here we have the rotor bars are there. The rotor bars are nothing but short circuited rotor bars are there. The short circuited rotor bars are nothing but the damper winding here. Okay, so this damper winding will come into picture when there is a change in the synchronous speed. Ns is the synchronous speed of the mmf of the stator, and let's nr are the nr is nothing but the speed of the rotor here. Okay, synchronous speed, we know that synchronous machine, we know that these two will be equal. Okay, so when these two will be equal, damper winding will not come into the picture. But when there is a slight differences, that is the synchronous speed, okay, is greater than the rotor speed, or the synchronous speed is less than this rotor speed, then the damper winding will come. So this damper winding is going to control the rotor in such a way that it should get its equilibrium value. Okay, so answer is, it is going to prevent the provide starting torque and prevent hunting. So hunting is nothing but, so this is the synchronous speed is greater than rotor speed, or synchronous speed less than rotor speed is nothing but a hunting. Okay, it's going to avoid the concept of hunting here, and also it is going to provide the short circuit rotor copper bars, so that the torque is going to be high, so providing the starting torque and preventing hunting. So option will be, so this is the answer. Next question. Three equal impedances of 10 plus J10 ohm are connected in delta across a three-phase balanced supply. The angle between the line current IR and the line voltage VRY is given by. In a three equal impedances, that means there is a, for example, let's take this and draw the equivalent circuit diagram. So let me take this impedance Z here. Okay, and here we have some impedance Z here. Okay, now let me correct it. Here we have some impedances here, like three impedances are there. They are connected in delta here. Okay, so let the current R phase, Y phase, B phase. Okay, and the voltage is nothing but VRY here between the two phases here. Okay, so here the angle between the line current and the line voltages, generally there will be a difference of 30 degrees plus here theta. So what is a theta? So theta is nothing but it's a load angle. Okay, so load angle is here. So this theta value, suppose for a pure resistive load, so pure resistive load, this angle will be equal to 0. Okay, now for a pure inductive load, this value will be 90 degrees. For a pure capacitive load, it is going to be minus 90 degrees, like that we can say. Now here in the given question, the given impedance, what is the impedance here? The impedance is Z is equal to 10 plus J10 here. That is a hint they given. That means it is having a combination of resistance plus reactance here. That is the here reactance here. Now we need to find the value of theta here. Theta is nothing but tan inversion of the reactive component here divided by resistive component here. So tan inversion of what is going to be 1. Okay, so tan inversion of 1, theta will be what, 45 degrees. So theta will be 45 degrees. So what is the total angle here? That is at 30 basic plus The load angle is 45 degrees, so it will be equivalent to 75 degrees. So answer will be B here. Okay. Next question here, the theory questions. For theory questions, I am not going to discuss in detail. Okay, the state of charge of the battery is indicated by the electrolytes. The state of the charge of the battery is indicated by its specific gravity. So answer is D for this question here. And next one, a load has per unit impedance of 0.6 to a base of 20 MVA and 33 kV. The per unit impedance to a base of 10 MVA and 11 kVA. Friends, if you are preparing for especially AE examinations, this is the standard questions they are asking from the power system subject, as you know. Okay, so this question is very important, and the concept is also very important. Okay, and you will see that most of the times out of the 99 out of 100 papers, you will see 95 question papers will have the question based on this concept here. So there is nothing big concept, just you remember the formula here. Okay, now I'll tell the answer for this problem. The per unit impedance of a new MVA, right? So actually X per unit, okay, you want to find the new value. N stands for new value. That is X per unit old into, right, MVA base. Okay, it's a base, it's a new value divided by MVA base old value. So old value into KV base old square divided by KV base new square. So this is the standard question. Okay, formula. Now here the old per unit value is how much? It is a 0.6. Okay, 0.6 into MVA new value. New base value is what? 10. So 10 divided by MVA in old value is 20 into KVB old value 33. 33 KV into 33 square means I'm writing here divided by 11 into 11. Okay, 11 1 11 3 here, 11 1 11 3 here. So if you are solving this, you will get the answer as it is 2.7 per unit. Okay, okay, so answer will be 2.7 here. Okay, next question. So B is the right answer for this question here. Next we'll move to the question here. A three-phase 6-pole induction motor runs with its rated speed, that is a rated voltage V, and rated frequency 50 Hz. The maximum torque obtained is Tm1 if the motor supplied with same voltage but frequency of 60 Hz. The maximum torque would be approximately, we know that the maximum torque is proportional to, okay, maximum torque is proportional to V by F whole square here. Now from this concept, here in the given question they specified that the voltage with the same voltage means V1 will be equal to V2. Okay, so I am not considering this. I am taking the form T max 2 is equal to T max 1. I am directly writing the proportionality here into, okay, so F1 square divided by F2 square here. Okay, now from this Tm1 value will be Tm1 as it is. F1 value will be what? Frequency at first case. So 50 into 50 F square divided by 60 into 60. Okay, so if you see the options here, okay, without doing calculations, you will say that A will be the answer. Okay, so Tm2 will be 0.7 times that of Tm1. Okay, so that will be the answer for the question here. And simple question asked from the transformers. In a transformer the core is laminated too, so very standard and basic question. Okay, if the examiner thinks that you want to get some theory questions, he will have a choice of this question. In a transformer the core is laminated to reduce what? Reduce it to what? Eddy current losses. Reduce it to eddy current losses only. Laminations are done due to eddy current losses. Standard question in any machine. Okay, if the core is laminated irrespective of machine, then it's for only reducing the eddy current losses. Next one, the voltage of a TC2 wire system operating at 200 volts is raised to 400 volts. The percentage saving in the conductor material gained if the same power is transmitted over the same distance with the same power losses. So here the concept of same power is transmitted over the same distance. So distance is not changing, losses are not changing, and same power. So here I'll take the help of power losses. So power loss formula we know. So P is equal to V square by R. So based on this concept, I'll take the formula. So P1 is equal to V1 square by R1. Okay, which is equal to P2, that is equal to V2 square by R2. Why? Because they said that same power transmitted and same power losses. So I'm taking this formula here. So from this, what will be the R1 and R2 relationship here? So what is a V1? So V1 is nothing but 200 into 200 divided by R1 is equal to, so 400 into 400 divided by R2. So from this relationship, R2 will be equal to what? 4 times that of R1. Okay. Now they are asking about the conductor material gain. So I'll write the formula. The percentage conductor material gain is equal to conductor material gain is equal to, okay, so it is R2 minus R1 divided by irrespective of R2 here. So R into 100%. So R2 is what? 4 times that of R1 minus R1 divided by, okay, so R2 is what? So R2 is what? 4 times that of R1 here. So it is equal into 100%. This is what? 3 by 4 into 100. So you know that it's a 75. Next one. The voltage across various discs of suspension insulators having identical discs are different due to, if you have seen the transmission tower like this, and here we have some conductors are there. Okay, so let's example here say support line support here, and here we have a insulator, and here we have insulator, and here we have insulator, and finally here we have a conductor. Okay, so conductor going like this. Now the suspension type insulators are having different voltage because of this insulator will have a metallic pin here and this metallic pin, and this pole is grounded like this. That means there exists a two metallic parts which separate some air here. So this will act as a capacitance here. That capacitance we can call as a shunt capacitance to ground here. So answer will be shunt capacitance to ground. Next one, the power dissipated in watts in the resistor are here. So simply see here, okay, so 6 amps, 10 ohms, 6 ohms, 10 amps. If you represent this network by using the source transformation technique, not source transformation technique, I can convert a current source is parallel with a resistor can be represented as a voltage source in series with the resistance here. Okay, so based on that concept, I'll redraw the circuit again here. That is V into I, that is 6 amps into 10. So 6 into 10 will be what? 60 volts. So plus or minus 60. And here the resistor is in parallel. I will connect into series. There will be a resistor here like this, and here also same. There will be a resistor here like this, and here we have voltage source of 60 volts here. So this will be what? 10 ohms, and this will be what? Sorry, this will be R, and this will be 6 ohms, right? 60 volts is there. Now apply KVL in this loop here. Minus 60 plus 10 into I plus R into I plus 6 into I plus 60 equal to 0. Minus 60 plus 60 gets cancelled. So simply I is equal to 0. As I is equal to 0, the power dissipated in I square R, that will be equal to 0. So answer is B here. So answer is B. Next one here. Okay, right. So consider the circuit shown in the figure. If the beta of the transistor is 30 and the input voltage is plus 5 volts, then the transistor would be operating in. So this is one of the previous year gate question asked for the ECE branch. Okay, and the examiner what had done in this question paper is, so he has minimized the some data. That means he has reduced some data here, so that the calculations will be made by you. It will be easier here. Okay. So if I am going to solve entire paper, it will take 2 to 3 hours easily. So I am just giving the hint for this question paper here, so that you can do at your home easily, right? So first I'll give the hint here. Okay. So first I will write the KVL in this loop here. I'll write right. So VI will be what? It's a plus 5 volts. So I'll start KVL in this loop. So minus 5 plus 20k. So I'm considering here current is I1, and here it will be I2, and here it will be I base, and this will be your collector, and this will be your emitter. And in between these two we have VBE, which is equal to 0.7 volts here. So minus 5 plus 20k into I1 plus VBE. So VBE is equal to 0. So once you simplify this, VBE will be value 0.7, and from this if you find the value of I1, which is equal to 0.215 milliamperes. And similarly, I will take the second loop here, that is minus 10. Okay, so minus 10 minus 0.7, that is VBE, and plus I2 into 100k ohms is equal to 0. So from this I2 value will be equal to 0.107 milliamperes. Now what is the base current? So base current, if you apply KCL here, it's a difference between entering and leaving currents. So IB equal to I1 minus I2, which will be equal to 0.108 milliamperes. So we got these three values. Now IC. So IC is equal to beta into IB. So beta value given 30, IB value got 0.108 milliamperes. So that it will be at 3.24, okay, milliamperes. Now you got this, right? Now VCE we want to calculate. What is the VCE here? So voltage across these 2 points is nothing but VCE. Okay. So in order to find the VCE value, so what is the VCE? From this apply KVL here, VCE is equal to VCC minus IC into RC. So what's the VC value? 12 minus IC value got 3.24 into RC value is 2.0 into 10 power minus 3 into 10 power 3. So simply get it as a 5.52 volts. Okay. Now as per the concept of this biasing, VCE is greater than 0.2 means that transistor will working in active region. So what is the value we got? 5.52. So 5.52 is greater than 0.2. So that's the reason why the transistor is acting in active region. Okay. Next question, friends. A voltage is impressed at the end of a long transmission line AB. The voltage is traveling along the AB has a two components, and first one is f of t minus x by v, which is a forward traveling component, and f of t minus x by v, which is a backward traveling component, where the v is the velocity of the wave and x is the distance traveled. Which of the following statement is true? So this one will be what? It's a forward, and this one will be what? It's a reverse. Okay, f of t minus x by v is a forward traveling component, so wrong option. F of t plus x by v minus f of t minus x by v is the total voltage, is wrong. And last option, f of t plus x by v is a forward traveling component, is a backward, wrong. So answer will be sum of these two is the total voltage at the time t, will be the right answer. Sorry. So next move to the question here. So it is a question that is asked in the op amps here. So here we have minus, here we have plus. Okay. Sorry. Okay. So this circuit is, so friends observe here, here the resistance and capacitance both are connected in series here. These two are in series. Then it acts as a what? It acts as a simply high pass filter. Okay. If the same resistor and capacitor connected like this, then this will act as a low pass filter. So the following op amp is a high pass filter with a cutoff frequency of R2 into C, 1 by R2 into C. So this will be the answer here. So C. Next one, from the control system. The polar plot of a feedback control system which is an open loop stable with a gain k is equal to 1 is given by. So here in the question they given that there is a plot of polar plot. So where we have the given the value boundary condition is minus 1 comma 0 and here we have a 0.4. So what is 0.4? Let's kc by k value is equal to 0.4. Okay, now kc value is what? 0.4 into k value is 1, that is a 0.4 only. Now second case, kc by k value is nothing but same 0.4, but kc value, what is happen? So k is doubled. Now k is doubled means 0.4 into 2 will be equal to 0.8. Okay, now observe here. Now the graph will be somewhere else here like this. Now here we have 0.8 here. Now see, observe here, when the gain k value is double, still it is in the boundary of minus 1. Okay, so still in the boundary of minus 1 means the system is still stable condition. So first option is the system is in stable. Now we know that k is proportional to 1 by square root of zeta here. Now as zeta k value increases means zeta value decreases. So zeta value decreases means we know that, okay, zeta is equal to 1 means critically damped condition, zeta is equal to 0 means undamped condition, zeta value is more than 1 means over damped condition here. As zeta value decreases, what about the oscillations? It is going to be increases, right? So answer is stable with a more oscillations in the step response. So answer will be C here. Next question. The unknown inductance, here the specified as L suffix X, is measured using Maxwell bridge shown in the figure. Now here the balanced condition for Rx and Lx are given by. So what is the balanced condition here? So it is Rx plus j omega Lx, opposite terms multiplication means R4, which is equal to R2 into R3 plus j omega L3 here. Simplify this equation here. Rx into R4 plus j omega Lx into R4, which is equal to R2 R3 plus j omega L3 into R2. So by equating this real and imaginary parts, so from this Rx is equal to R2 R3 by R4, and similarly Lx into R4 is equal to L3 into R2. So from this Lx value will be what? L3 R2 by R4. So which option will matches? R2 R3 by R4. Lx is equal to L3 R2 by R4. So this will be the correct answer for this question here. Okay, and we'll move to the next question here. All right. Now, if an unsymmetrical line to ground fault occurs at the terminals of a delta star ungrounded transformer, then, so we know that the switching diagram of this transformer, so here we have the switching diagram like this, here we have some inductance, and here we have switches like this. Okay, and here we have switches, these are nothing but parallel switches here. Okay, so here we have switches like this, and now I'll write, okay, this is switches here. So this represents star, delta, delta here. Now unsymmetrical line to ground fault has been occurred. The primary winding is what? Delta means. The primary winding is delta means this will be closed here. Secondary winding is star ungrounded. So ungrounded means it will remain as it is open here. So if we redraw the equivalent circuit, then this is the open circuit here. Here we have winding. Okay. So here is short circuited. And what about here? So this will be open circuited and this will be open circuited. Okay, see here. From primary side open circuited, secondary side also open circuited. That means the zero sequence currents are absent on the both the sides of the transformer here. Suppose in case the star is a grounded means then there will be zero sequence currents absent in the primary but present in the secondary like this. Okay, but here both are open means zero sequence currents are absent in the both sides of the transformer. Next one, the Peterson coil is used for. What is this Peterson coil? Why we are going to use? In case of transmission lines, for example, LG fault occurred in the three-phase transmission line here. Sorry, not LG fault. It is just open circuit of the conductor. One transmission is open circuited. So it is a R, Y, B. Okay. If it is a touches with the ground means then we can call it as a line to ground fault. Okay. But one line is just open circuited. Remaining two lines are healthy. At the time, the remaining two lines will experience a higher voltage when compared to normal condition. So higher voltage will be there. So if the higher voltage will be there, what we will do? We will place a inductor to make the voltage in control. That coil is called as a Peterson coil. That is nothing but inductive coil. So L is nothing but 1 by 3 omega square. So this is a value here. Okay. So remember this value. You may ask her some questions based on this formula here. Okay. Just remember here. Next one. The HRC fuse provides the best protection against. So HRC fuses will provide best protection against short circuit here. For lightning and over voltages, what we will do is we will place surge arrestor or lightning arrestor. And for overload conditions, so for overload, what we will do is we will place MCBs. Okay, MCB will place so that the load is going to be trip here. Okay. Next one, they given a program here 8085 program below MVI A comma BB LXI B comma 2060H stacks B here. So generally what will move means the BB will be moved into A and LXI B means 2060H is moved into B here, and now stacks B means what are the value of AB BB is there that is moved here. That means the answer will be after the program is executed the contents of the A and the flag which is set to be. So the content of the A will be BB and there will be no flag set here. So answer is D here. Okay. Next one. From an open circuit test of a transformer, the no load power factor was determined. Out of the following choices, which is mostly the value? We know that the no load power factor means it will be in the range of 0.2 to 0.4. Okay. So generally open circuit test is performed at the rated flux condition and the short circuit test is performed at the rated current condition. So when we are performing the rated flux condition or rated voltage condition, the current drawn from the primary winding of the transformer will be very low. Okay, and the current is used for the making the core magnetization. Okay, that is the reason why the primary winding will act as a pure inductor. The power factor will be around 0.2 to 0.4. Okay, ideally speaking it's 0, but in case of practical conditions there will be some resistance is present, so that the 0.2 to 0.4 will be the answer here. Next one, the principle of thermocouple is based on. The principle of thermocouple is based on the Seebeck effect. What is the Seebeck effect, sir? Seebeck effect is nothing but whenever you are given some input, okay, so input to the two wires of different materials, then they will experience a temperature difference at the output. Okay, so what is the input you are giving here? The input is nothing but the temperature. Output will be proportionally EMF here. So input is what? So input what you are giving to the wires are nothing but say temperature difference. Okay. And output what you are getting is it is nothing but the EMF or current. Okay. So similarly, the Pelter effect is opposite. In Pelter effect, you will give EMF as an input and output will be temperature difference is nothing but the output here. So these two are the exactly opposite to each other. So opposite to each other here. Okay. So answer is Seebeck effect here. Next one. So consider the following statements. Okay. IGBT has a low input impedance compared to PMOSFET. IGBT and P MOSFET are both voltage controlled devices. IGBT can be designed for higher voltage compared to P MOSFETs. IGBT converters are more costly and bigger in size compared to BJT converters. So exact answer for this question is that IGBT and MOSFET both are voltage control devices. Okay, voltage control devices, and IGBT can be designed for higher voltage compared to P MOSFETs. Why? Because the switching frequency of this P MOSFET is very high. Okay, that means the power handling capacity is automatically less. So in order to avoid the drawback, they made a mix of this power MOSFET and the power BJT, and they made IGBT for operating at higher voltages. So that's the reason why. So option 2 and 3 will be the right answer here. Next one. In a diode rectifier circuit shown, the permanent magnet moving coil meter will read. So here the given question, they directly what they given is they simply directly given a diode with a inductor here. So inductor is there. There is no resistance, so that it acts as a pure inductor. What is the conduction angle of this diode? It is going to be completely 360 degrees. Why? Because it's continue to conduct. Now here they given what will be the current here. Okay, what is the current read by this PMMC? So PMMC coil will read always average value. So average value only. So what is the formula for average value of this inductor and circuit here is nothing but it is I average is equal to, so I maximum output maximum IMO value by 2 here. What is the IMO? IMO is nothing but 2 Vm by omega into L here. Okay, into 2. Now, what is the value? Maximum value 200 into 2. Omega value is frequency is 100 into 1. Okay, into 2 here. So 2 gets cancelled. 200 by 100 means it's simply 2 amps. Answer will be C here. Okay. Suppose if they ask what is the maximum value means you will find the maximum value here from this formula. Okay. So IMO is equal to 2Vm by omega into L. So this is the formula here. Next one. A dummy strain gauge is used in a quarter bridge strain gauge circuit 2. So it is to compensate for changes in the temperature and the lead well resistance here. Okay, next one. LVDT is used to measure what? So it is used to measure the displacement here. So linear variable differential transformer here. Okay, next one. Slip test is performed. So slip test, it is a performed on the no load, and it is used to find the quadrature axis and direct axis reactances of a silent pole alternator. So answer will be B here. Okay, and we'll move to the next question here. Right, a transmission line 200 kilometers has certain ABCD parameters if the length is reduced to 60 kilometers. So remember here, this is a standard question here. So where the area means, or not area, so constant A or parameter A is proportional to 1 by length here. Okay, and here next one constant B is proportional to length here. Okay, now if the A length is decreased here, that means A will be increases automatically, and the length is decreased means B value will be decreased. So answer is A will increase, B will decrease. So answer A will be the right answer here. Next one. Okay. Load compensation power system is a process too. So load compensation, why we are doing? Okay, for example, in a Faraday effect, what will happen? The output voltage will be higher compared to sending end voltage. In order to control the Faraday effect, we are introducing some shunt coil at the load side so that the voltage can be controlled. That means maintain better voltage profile here. So that will be the answer here. Next one, so question number 28 here. A 5 amps ammeter with a zero point 0.3 resistance is to be used to measure current in a circuit which draws a current up to 20 amperes. The shunt resistance to be used along with the ammeter. So this is also one of the standard questions that are asked in the examination, right? So RSH is equal to Rm by M minus 1. So M is nothing but the maximum current rating. How much it is? 20 divided by 5, which is equal to 4. Okay, so Rm value is 0.3 divided by, okay, so 4 minus 1, 3 means it's nothing but 0.1 ohm. Answer will be 0.1 ohm here. Okay. In a PMMC instrument, the damping is provided. Permanent magnet moving coil means the damping is provided is nothing but eddy current damping. You know that basic concept. Okay, eddy current damping. Why? Because the magnetic field produced by PMMC instruments is higher compared to electrodynamometer or some other equipment, right? Which of the following is true for a bus impedance matrix? Okay, it's not a sparse matrix. Why? Because bus admittance matrix is a sparse matrix and it has diagonal dominant elements. This is also wrong. Okay, it is the inverse of the bus admittance matrix. So we know that y is equal to z inverse, or we can take it as z is equal to y inverse. So each element of its reciprocal of the corresponding element is a wrong statement. So among the statements, the correct statement is C. Okay. Next one. A single phase voltage controller 220 volts 50 Hz and a load of 10 ohms for a 9 cycles on 7 cycles off, the RMS output voltage and the input power factors is. So RMS output voltage will be, so VRMS in case of a cycloconverter is square root of delta into V naught here. Okay, or Vs we can say Vs. Okay, delta will be what? So delta is nothing but T on by capital T. So T on is 9 divided by half means 7 plus 9 is nothing but 16, 9 by 16 here. So square root of 9 by 16 into Vs is what? 220. So it's nothing but 3 by 4th of 220. Okay, so I'll get it as 171 volts and the power factor is nothing but it is square root of delta. Okay, so it is equal to what? 0.75 here. Okay, so for this answer will be, sorry, let me check here. So it will be 165 volts and 0.75. So answer will be C here. Okay, we'll move to the next question here. The range of frequencies used in the induction heating is in induction heating, the frequency range will be the power frequency range. It is a more than 1 kilohertz. It is not in the power frequency ranges. Okay. Next one. Consider the following statements. The magnetizing current in a transformer is sinusoidal. It's a wrong statement. The magnetizing currents in the three-phase supply lines of three-phase transformer is sinusoidal. Correct statement. The magnetizing current in a single-phase transformer is a non-sinusoidal. It's a peaky wave in nature. So peaky wave in nature, but the induced voltages are sinusoidal. Okay, if you are studying the concept of the magnetizing currents in a transformer, we are intentionally introducing some harmonics in the three-phase transformers to get the output voltage sinusoidal here. So options are, the options 2 and 3 are the correct options here. Okay. A generator is connected to an infinite bus through a double circuit line as shown in the figure here. Okay, so here the given the circuit diagram of a power system in which we need to find the value of this admittance parameters y1, y1, y12, y22. First, what we will do is we will convert these x values into its equivalent y parameters. So I'll right. So I'll check. Okay. So write down here. So capital Y11 is equal to small y11 plus y13. Okay. What is the first small y1? It is 0 value. Between the 1 and 3, that is 0.2. Okay. So small y13 is equal to, it is 1 by j 0.2 is nothing but minus j5. Okay. Similarly, minus j5 value got it here. And similarly, you need to find the value of y22. Similarly, what is the y22? Is nothing but small y22 plus small y23. So it will be equal to minus j5. Okay. So likewise, if you are finding all the parameters of this matrix here, the resultant values will be, okay, so minus J5, 0 plus J5 and 0 minus J5, okay, and here we have plus J5 and finally plus J5, J5 and minus J10 here, okay. So among the options here, check which option is best suitable. So here, no, it's not matching. Minus J plus J4, J5 minus J5 not matching here. So option B is going to match with the answer here. Next one. The supply for arc welding is, okay, the supply for the arc welding is, generally arc welding will have a low voltage and high currents, either it may be DC or it may be AC voltage here. So generally prefer for high current, AC current, okay. And in some cases you can use DC also. So answer will be low voltage, high current, AC or DC voltages will be the option here. Next one, for the simple chopper circuit shown, the average and RMS values of the currents for the duty cycle of 0.49 in amps, okay, and neglect the voltage drop across the chopper here. Here you need to identify what it is a kind of this chopper here. Either it may be step up chopper or step down chopper. So this is a step down chopper, or we can also call as a, this one as a buck converter. So buck converter is there, okay. Now here the voltage is Vs is equal to 200 volts and the duty cycle is 0.49. Now what we need, average output voltage. So V naught is equal to delta into Vs, 0.49 into 200. Okay. So but here they are asking currents. So currents means, so simply I naught is equal to delta into Vs by R, which is equal to 0.49 into 200 divided by 10 ohm resistor. This will be equal to what, 9.8 amperes. And next one, duty cycle of 0.49 is given and RMS value. So I naught RMS is equal to, okay, so 200 by 10 into square root of delta here. So 200 by 10 into 0.7, 0.07, right? So this will be equal to what? It's about 14 here. Okay, so 14, or at 0.7 here. So 14 amps will be the answer. Okay, so 14 amps will be the answer. So please cross check this calculations here. Okay, next one. A 2 kilowatt 200 volts 1000 rpm DC series motor. The torque at full load was found to be 0.3 newton meter. The torque at half full load will be here. Okay. So first of all, find the value of this current here. Armature current. Armature current will be equal to 2000 kilowatts means 2000 watts divided by how much, 200 volts. It's nothing but 10 amperes are given. Okay. Now T proportional to Ia square. So T2 is equal to T1 into, so it is I2 square by I1 square. So T1 value will be what, 0.3. I2 is the next current. Okay. So I2 is the current means it is reduced to half, means 1 by 4th into 1 by 4th into uh, I1 value. So I1 value will be, this will be I1 square by I1 square. So answer will be what? It is 0.075. So answer will be C here. Next one. If the Z transform of A power K is Z by Z minus A, then the Z transformer of K into A power K is given by, so it is given by minus Az by Z minus A whole square. It's a wrong statement. So this will be the answer. So plus Az by Z minus A square. So please correct. It is Az by Z minus A whole square. Next one. The open loop transfer function with the unity feedback is given by G of S is equal to 1 by S into S plus 2. The poles of the closed loop system will be. So closed loops transfer function is equal to open loop transfer function divided by 1 plus open loop transfer function. The given transfer function is open loop transfer function. Again, if you simplify this, you will get this one as, okay, 1 divided by s square plus 2s plus 1. Okay, I'm saying about poles here. Okay, so poles, some x value divided by this poles will get it here. Okay, now x will be 1. So s square plus 2s plus 1 if you solve is equal to 0 means if you solve this, there are the two poles. There is a -1 and -1. So this will be the answer here. Okay. So check it once. The answer will be C here. Next one. For using the regenerative braking, the most suitable motor is. Okay. For regenerative braking, the most suitable motor is it's a slip ring induction motors. Okay. So that's it for this session, friends. Next 40 questions I will discuss in the next upcoming videos. Okay. Thank you. If you are new to the YouTube channel, please share the content with your friends. Okay. And make the channel better performance, right? Thank you. Have a nice day.